right now, all you're seeing in here is the basic course document things, okay? And that's, okay, this is the first time through this class with this particular software package, so as we go through the semester, I will have the videos up there. I will have additional information in there for you, okay? So what we're going to do today is the first thing we're going to do is go over the course syllabus. You're not on? Okay. Why don't you come up and look on with somebody? Somebody that's on, that's getting the broadcast. Okay, hang on a minute. Just look on with her, Sherry, for right now. Before we start, all right. Obviously, you know you're at Ori Georgetown Tech, right? Okay. Yeah, that's what they call it. All right. We're going to be designing and writing object-oriented programs using Java. This is your text. Somebody, Sherry, hold your text up. It's a pretty green book, black and green book, looks like that. You have to have it. The reason you have to have it is because it has an access code to My Programming Lab in there. We will be using My Programming Lab, and you can't get into it without the access code. All right. Okay. In our concepts, all right, one of the things that we will be talking about is object-oriented programming and object-oriented program development. In the past, as I'm sure several of you know, we've used VB for this, all right? We've gone to Java this semester for several different reasons. Number one, we're adding mobile apps classes. The Android mobile apps class is in Java, okay? Number two, in order to add the Android mobile apps class, we had to take away our Java class. We wanted our students to have at least 2 languages. And so we thought that this was a good place to put the Java. In addition to which, the My Programming Lab is available for Java and not for VB at this point in time. This is an important tool that we think will help even those of you who don't want to be programmers, who are network specific, to get through this class easier. All right, so that's why we're doing it. Now, we're going to use Java, and we'll work with classes, procedures, decisions, and loops, as well as using built-in classes from the Java SDK. We will also ask you to tell us what a particular Java program is going to do by looking at the code. That's not as hard as it sounds. Then we will also be using the Eclipse Java IDE, and it's a very simple. Actually, it takes care of a lot of things that there's lots of Java interface development environments out there, and this is probably the best for being helping you to do this. And since this is an entry-level class, we want to give you the support you need, as opposed to tying you up in all kinds of little garbagey things that you might have to do in Java. Here is our basic course outline. Now, in My Programming Lab, there are videos, okay? You can watch them. They are optional. They cover pretty much the same thing we will be covering in lecture, but with a little bit of a different twist, and it's a different person lecturing. So, you know, if you're having trouble understanding a concept, by all means, go look at them. Reading assignments. You will read in this class, okay? Now notice, this is not, like chapter 1, does not start on page 1, all right? And that's because the very first part of this chapter deals with things that are covered in other classes, like the interior of the computer and all the rest of that nonsense, which we don't need to do in a programming class. Okay, you will have programming projects and you will have a test on every chapter. Now, the test will be based on the lecture, which is one of the reasons why I'm recording it, and on the programming projects. Now, I believe the first test is based solely on the lecture, simply because we're not into that many difficult, anything really intense with Java. But one of the things we will be asking you to do on a test is maybe find the error in a Java program, maybe explain what a set of Java code does. All right. So that's the type of thing we will be asking you. We will be covering all the way down to chapter 7. And you'll notice that the exercises are coming from my programming lab. And we'll get to that in just a minute here. But what we have here when we deal with my programming lab, the stuff is automatically graded. So you will know whether you got the question right or not. Some of the questions are fill in the blank, some are multiple choice, and some are programming code. So, you know, it'll be interesting to see. This is the first time we've used this. And I'm telling you that up front, but it's a proven product. Okay. Hang on here. All right. Our course artifacts are the online test grades, the programming, we have the programming structures, and then the classes and procedures. All right. Your test will be worth 30%. Your lab assignments, which is the programming exercises the exercises in my programming lab, are worth 30%, and your programs are worth 40%. Now, you will have to spend some time on my programming lab. That's why that is worth 30%. So when you look at the exercises you have to do, you remember that's worth 30% of your grade. The other thing about it is it automatically tells you whether the answer is correct or not. So if it's not correct, you can go back and fix it. All right, within the time limit allowed. Okay. All right. I am committed that everyone can pass this course. I know I have networkers in here. I know I have people who could care less about programming in here, as well as programmers, all right? But the bottom line is, this course is an entry-level course to programming. Your 168 course dealt with flowcharts. It showed you all of the programming structures. Here's the first time you're going to be using program code. So we have made it, Ms. Waring and I have developed it this semester so that it's perfectly possible for everybody to pass it if you do the work. If you don't do the work, you don't stand a prayer. I'm being perfectly honest with you, okay? Ask students who've had me in my other classes. You do the work, you can pass the course. You don't do the work, you can't pass the course. Don't come to me and tell me it's too much work. I don't want to hear it. I mean, I'm going to be very frank with you. I don't want to hear it. It's what's required to get through this course. Okay? You have to have this course with a C or better in order to graduate from this department. It's always easier to do things once instead of twice. Why am I pointing this out? Because if you get behind, you're dead. And that, I'm not threatening you, I'm simply explaining it to you. If you get behind, you're in serious, serious trouble. Because there's a lot of work involved, and you won't be able to write the programs that you need to write because you won't have the background to write the programs that you need to write. The other thing you have to do to this class is come to class. I will give you every example. I will help you all I can. But I can't help you if you don't come to class. I can't do anything with you. Now, we do have a tutor in the SSTC. Nick is sitting in our class because he wants to see how the 187 class is going to run since it's changed. He will be tutoring in the SSTC. So if you find you need help and it's not enough to come to class and it's not enough to look to the required videos and stuff, go see Nick. He'll be happy to help you. Please, don't drop out of the class. It messes your life up. If you drop 187, you cannot take database in the fall. Database is another required course. It will put you a full year behind in graduating. I want everybody to understand the consequences of this. All right? Don't drop it. It really messes your life up. All right? I had a student this fall. He was done with absolutely everything, but he could not get his diploma till he came back and got the database class. He had to pass the 187 class last spring and then come back and get the database class this fall. Now that's a steep price to pay. All right. So make up your minds right now. You're going to stay in the class. You're going to do the work. You're going to get the grades, and you'll be done with me. Until database, that is. All right. I lose my voice if I don't have a drink. Drink has lid on it, very comfortable lid. Okay? If you're going to have a drink in here, no cups from Arby's or something with the flimsy plastic lids on. You can bring a bottle in and have screw-on cap. Okay? Anything gets spilled, everybody goes on restriction and nobody's allowed to bring anything. All right? I don't take late assignments, period. I just don't. So don't ask. We'll get along fine. I won't have to tell you no. Having not taught this class before using the programming lab, I'm not sure how much time we're going to have here, there, or whatever. All right, and it says majority of courses in the department students are expected to complete the lab assignments outside of class. I'm not sure where we're going to be. Okay, because we're going to be doing a lot of samples in Java and a lot of samples using Eclipse, especially at first, learning how. So therefore, I would expect that my programming lab stuff would have to be done out of class. But at this point, I don't know. All right. Just know that you are going to have things you have to do outside of class. You can't copy this software. We all know that. That was in there from when we were still using DOS. One thing you have to be aware of, systems are, as soon as you turn your system off, any files that you saved on this system is purged. So you will lose your work, period. Make sure you have your USB drives. Come to class with them all the time. Now, if you forget your USB drive, it's not the end of the world. I will show you how to upload it into the locker in D2L where you can get it back down. But don't make this a habit because the locker doesn't hold all that much. I monitor you guys, even when you're working, to make sure, A, you're not having problems, B, you're doing what you're supposed to do, and C, you're not on the internet doing in some site I don't want you on, okay? Make our life simple, all right? Just don't use the internet when you're supposed to be working in this class, and nobody will have any trouble. If you do, I will lock your computer in a heartbeat. I promise you I will. Make sure your cell phones, beepers, pagers, and other electronic devices will be turned off prior to coming into class. Okay. Once your phone goes off in one of my classes, you're mine for the rest of your stay here. I have you for another class. I will remind you about that phone every single time I have you. All right? Make it simple. Turn them off right now. If you have a daycare situation or a child situation or something, I put it on vibrate. Okay, we can work those things out. Even if I am not here, this is not a party room. All right? Just because there's no glass doors there when people can't see anything, I expect you to behave in a professional manner. If students are in here working, I will be in and out. If you're not behaving in a professional manner, I will kick you out. Just that simple. You're going to show respect. We just had that. Oh, yeah. And, you know, every so often I get somebody who gets really upset with me because I won't take a late assignment or something like that. Don't threaten me, guys. You know, just don't go there. All right? Don't go there with any of your any of your professors. It's not worth it because we take it very seriously around here. We will call security. They will arrest you. They will take you to jail. Don't do it. Yeah, it's not worth the aggravation. Trust me. Sleeping. Sleep in my class. You'll be back to see me next spring. Okay? No problem. Yeah. Take responsibility for your learning. Okay? Ask questions. Guys, I don't read minds. It drives me right up the wall when somebody says to me, well, I didn't understand that. Well, why didn't you ask me? Stop me. Ask me. It's the only way I know that you're not getting it. Even if I'm in the middle of a lecture, stop and ask for clarification. I don't care. I'm fine with that. But make sure you understand what we're doing, especially when we're working on the actual languages. Stop me. Don't sit there and get lost when we're doing a program all together because you were too embarrassed to ask a question. The only bad question is the one that doesn't get asked. So don't do it. Don't cheat. I've been doing this almost 25 years. I will catch you. When I catch you, both people involved get zeros. Period. It's just that simple. It's not worth it. Even a 50 on a program is better than a 0. Be in class. If you're not in class, you're in trouble. All right? You never know when one of your classmates is going to ask a question that will trigger a discussion that will have some very important information in that you will miss because you aren't in class. And yes, I'm recording it, and yes, I'm posting it. That is not an excuse not to come to class. I don't do tardy. It's very simple. All right. Most of the time, and I want you to understand this is not because I don't trust you. I will use Net Support School. When you're teaching a programming class, one of the things that the students have to be able to do, we're turning the air down a little bit, has to be able to do, you have to be able to read the code, okay? If I put it up here, you can't read the code. So I will take control of your computers. It has nothing to do with trusting you or anything else. It's so that you can see what's going on. We will often work together, okay? In which case, I expect you to be working on your program and nothing else. Don't type something in and while I'm helping somebody else, trot off to the internet. No, you have to be paying attention and concentrate on what you're doing. Life will be much easier. You can make up only one test per semester. I have no control of it. It's a departmental policy. If you're going to be absent, you must call me before the test. So in other words, you have to call me before 10:30 on the day of the test. You may leave a message on my answering machine. I will get it. If you email me, that is also acceptable. Now, I am always on time for class unless Mr. Luce gets me in the hallway to do something else, all right? So, if I'm not here, I will be here. If I'm not here in the building, someone will come and tell you what to do. You will have class. Okay, here is my phone number in my office. Here is my email address. I would prefer that you email me in D2L. Sometimes students' emails go to my spam. Not all the time. That would make it too easy. Not everybody's email. Only somebody's emails. Just email me in D2L and I know I'll get it. All right? Does anybody have any questions about this? I want to go back up to the grading policy one more time. Whoops. All right. The test will be multiple choice, short answer. They will be taken in D2L. The lab assignments are automatically graded by my programming lab. The programs will be graded according to a rubric. Now, the rubric tells you exactly what we're going to points and how many we're going to take off. This will be posted in D2L before your program is due, so that you will be able to see it and know what you're being graded on. All right. It's not to say that that's the only thing that's important from the program, but that is to say is you need to make sure you have this particular information. All right? All right. Any questions? Yes? No. Programming languages, language courses, by their very nature, are automatically cumulative. Because if you're going to write a program, as you know in 168, you did sequence and then you added if statements and then you added loops. So they're automatically cumulative. And because of that, I don't give a cumulative final. I simply give a test on Chapter 7, which is cumulative. All right. Now that test may take place during the final exam period. All right. But there is no final that's going to be worth more. All right. Any other questions? Okay. All right. Surely it will pop up here. All right. This is my schedule. Don't know how that got screwed up like that. Okay. As you will see, Mondays, I am really, really tight. I have just about enough time to eat lunch. Okay. Wednesdays are better. So, if you're only on campus Mondays and Wednesdays, you can see me before class, or you can see me after class on Wednesday. Monday's going to be a pretty much, don't even bother to try, okay? Other than in class, of course in class. Okay, if these office hours are not convenient for you, then you can come and see me. We'll make an appointment. As long as I'm not in class, I'll be happy to meet with you. Fridays. I don't do a formal tutoring session the way they did in 168, but I am always here on Friday mornings. So if you want to come in and work on Friday mornings, or any other day, that's perfectly all right. If I am on campus and I am not in class, I am available to you. So if you're in here working and you run into a problem and you want help, my office is all the way around on the other side, okay? Room 334, okay? It's right beside Mr. Testner's. So, feel free to come in and ask me questions. Now, one of the things about this class, when you ask me questions, I will give you answers. I may not tell you how to fix something exactly, but I will give you answers to help you find your way. All right. Okay, class schedule we already went over. Course learning outcomes, course evaluations. If you need the D2L guide to students, there it is. Tutoring service through the SSTC. Nick, tell them how they can sign up for tutoring services.
The actual instructions for that are actually on Wakehead. If you go to the campus lines, there's a link for tutor track, and then there are instructions right below that.
Everybody hear that?
The second you register for courses, you'll get figures on it. Sort of the most important for it's very straightforward. It's just, I will always be in the tutoring center because I think that's sort of what I always felt like everybody has to go to queries for this.
Okay. Good deal. And that goes for any of your courses. So that tutoring is available. The tutor track is available off of WaveNet, and I encourage you, if you even think you're having a problem with the course, go see a tutor early. Don't wait until you are so far behind you have no clue what you're doing.
That's the case for me every week, not because they don't get it, they just want to reinforce what they learned in class.
Yeah. Okay? I mean, I'm serious. And I'm not just talking about computer classes. I'm talking about any class. You know, math, whatever. If you just do it early, it's usually fixable. If you wait until it's like, I don't know what I'm doing, and I have this project due Friday and it's Thursday. No, that's not what the tutoring center is not going to be able to help you much there.
Please do not try that. I have seen that it doesn't work under any circumstances.
Okay? All right. So, we're going to start talking about chapter 1 today. Maybe, if it decides to behave itself. There you go. All right. Like I said, the first part of chapter 1 deals with hardware issues and things like that, and we're not going to deal with that in this class. That's not what this class is for. You've covered a lot of that in the 209 class and some of your other classes. Oops, wrong class. Wrong class. Don't want to give you that lecture. How many in here are thinking in terms of a programming major? Several of you. Good. Good. Okay. All right. All right. This is our book. Okay. The focus of the course is object-oriented software development. We will look at problem solving, program design, implementation, and testing, object-oriented concepts such as classes, objects, encapsulation, inheritance, polymorphism, graphical user interfaces, and the Java programming language. Okay? Now, the problem solving you're already familiar with, because that's what you did in 168. When you had your flowcharts and your pseudocode. We're going to do things just a little bit differently in here, and I will tell you, I will give you the exact way in which we're going to design our programs. All right, we will work on that as well as other things. We will be coding in Java, and we will be using all of these concepts when we do that, because Java is an object-oriented language. In VB, you don't necessarily have to use classes or object-oriented techniques right off the bat. In Java, you do. There's no getting around it. It's just the way it works. Okay, so this lecture, we're going to be concentrating on program development, object-oriented programming, and Java programming language. When we look at the mechanics of developing a program, first we plan the program. Now, we plan the program using a flowchart or pseudocode, IPO chart. That's the way, you're familiar with this, again, from your 168. What you were doing in 168 was planning programs. Once you get them planned, then you're going to write it in a specific language, such as Java. Once it's written, then we have to translate it into a form that the computer can execute. What you are writing is the English language version. The computer doesn't understand English. It understands binary or source code. So it has to get it to that form in order to be able to use it. Once we try to execute it, it's going to come back and it's going to tell us if we have any errors. If we have errors, then we have to fix them. Now, there's several different types of errors. There are syntax errors, which means you screwed up the code. There are runtimes errors, which means you get the wrong answers. And those are actually sometimes harder to fix because that means somewhere in the program design you made a mistake. You made a mistake in your logic, so you get the wrong answer. Those are sometimes much harder to fix because you have to go back and change your program design. But excuse me, before you turn the program in, all errors must be removed. Period. There's no in or out of there. We're going to use software tools, and the software tool we're going to be using is the Eclipse IDE. Okay, and we're going to take a look at that along with the programming lab on Wednesday. Now, I will tell you right now, I have the same class on Tuesdays and Thursdays. So if I say Thursday instead of Wednesday, just bear with me, and we all know what I'm talking about. Okay, there are 4 programming levels. There is machine language, assembly language, a high-level language, and a 4th generation language. Machine language is binary. Zeros, ones, whatever. That's what the very first programs were written in. As a matter of fact, ENIAC had like 64,000 switches, and you had to turn each one on or off in the correct method, the correct order, in order to make the thing work. And then you could run it, but that was only if one of the vacuum tubes hadn't blown. It had issues, all right? Assembly language is the next level up. As people started working with assembly language, or binary, machine language, they realized that they were doing some of the same things over and over again. So they made a little language. When I say little, I mean little language. That made it a little bit easier to do some of these things. So they would say add 2, 4. And something like register and a number, and then 2. Register and a number, and then 4, and then register 2 plus 4. Those types of things went on in assembly. Now, assembly was a step up from binary because you weren't coding ones and zeros. All right. Then we get to the high-level languages. Fortran was the first high-level language. Formula translation is what Fortran stands for. It was developed for scientists. It was excellent at handling math and scientific functions and all those types of things. It was absolutely terrible at handling names and all kinds of other, I'll get out here, all kinds of other data. Thank you, character data. Mine went blank. It's character data is what I was trying to say. All right. You then came up with COBOL, which was Common Business-Oriented Language. COBOL was wonderful at handling names and stuff because it was developed for business. But if you had to do a mathematical function in it, it was terrible. So they both had their strengths and their weaknesses. Other languages have come out of there. Now we're much more familiar with the languages that run on the PCs, such as Visual Basic or Java or C, those types of things. And to a large extent, the differences between the machines that can handle character data and the machines that can handle math data is gone. Because to some extent, that was actually not just the language, but also the computers that were involved. A 4th generation language is something like SQL. SQL, or SQL, is what we use to query a database. Right? It's also, 4th generation languages can also be the language generators. Like we have, and one of the reasons that we don't worry about COBOL and stuff so much is because there are actually programs out there that you type in exactly what you want to do and it'll write your COBOL program for you. And there are some other 4th generation languages out there, but that's the difference basically. One of the things is when you were working with a CPU or with a machine language, you had a different, and assembler, both of those. Every computer had its own machine language and assembler language. So if I was working on an IBM machine, I had one set of code. If I was working on a DEC, or digital equipment machine, I had another. If I was working on a Burroughs, I had another. So nothing could be run cross-platform, nothing. And that was an issue because it wasn't an issue for the computer manufacturers. What it meant for the computer manufacturers is once you had an IBM machine, you stayed with IBM machines because your programs didn't run on anything else. But it was an issue for companies. The other levels, the high-level language and the fourth-generation language, were developed to make easier for humans. Computers could care less. A language has to be translated into a machine language before the computer can run it. Does not matter whether we're talking COBOL, Fortran, C, VB, Java, I don't care what it is. You have to convert it first, all right? And that uses a compiler. Now, a compiler translates source code into the target language. One of the things that made Java different is Java was developed to be a portable language. Portable meaning it could be run, one program could be run on IBM machines or Burroughs machines or digital machines. It's because what Java does is Java converts to an intermediate language. They change it into something called a bytecode. Now that bytecode is not specific to any computer type. What it is it's a machine language, all right, but it's a generic machine language. So what you do is you take this bytecode and then you have an interpreter, and the interpreter changes the bytecode into the machine language. So if I'm running it on an IBM machine, the bytecode is translated into IBM machine language. If I'm running it on a Burroughs machine, the bytecode is translated into Burroughs machine language. The architecture neutral concept that Java created was new, was totally foreign to everything. And when it was developed, obviously a lot of people didn't like it. Because right now we have UTIDE. You know, I can write COBOL. Once I get you on my IBMs, you're not going to change vendor because you'd have to change every single program you have in order to run on a Burroughs machine, if that's what you want to do. So you had some real advantages. Java was the first nail in the coffin, shall we say, to that type of thinking. Because, oh, I can write a Java program. I can run it here, I can run it here, I can run it here. Bye, guys, I can do whatever I want. Now, in addition to that, about the same time that Java was introduced, you had this whole transformance to networking, network computers. In all seriousness, when I started teaching, one of the things we taught in 101 was that if you had a phone line into your mainframe, you had a security problem. Right in the book, swear to it. Now, everybody's networked everywhere, right? So there's been this whole transformance of thinking all the way through. Instead of huge machines, room-sized machines, or at least very large machines, we have a room full of networked routers, disk drives, controllers, and whatever else we need. Okay, Java fit right into this. It just came right along, started off with, okay, here I'm going to do it between mainframes, and then it says, oh, well, yeah, I don't care. I'll just flow right with it. I can do this all I want. So Java really came along at the right time. So you put this into a Java compiler. Once we design, okay, so we have a design up here. Once we design it, then we code it. The source code goes into the Java compiler. All right. Then the compiler changes it to bytecode. Now this is where you are going to get your errors. So when you write a Java program, if you're given errors, the errors are coming out of here. Okay? Now, once it's in bytecode, we can go to a bytecode compiler, and that'll move it to machine code, and then it will execute. But it's not going to do from here to here to here until all your errors are removed. Now, to some extent, the Eclipse IDE makes that easy because it helps you to find your, it's very good on helping you to find your errors. This is the one we're going to use, Eclipse. The reason we're going to use Eclipse is it's the most straightforward that I've seen, but in addition to which, if you are taking the programming track, when we get to the mobile apps class, that's the one that will enable us to do Android apps. They have a tie-in with Android. NetBeans is good, it's a Sun product, but it has a very specific beans that you have to develop, and they're kind of, it's a Sun thing. This one isn't bad, but there's still, and neither is this, but there's still a lot more stuff you have to do. You can download Eclipse to your own computer. It is free. And when we start with it, I'll give you the address where you can, well, that was not nice. I don't know what I hit. Okay. Let's try this again. Okay. Okay. Syntax. Now you had some syntax in Raptor, but not as much as you're going to get into in Java. The most common types of errors are syntax errors. Syntax errors are simply a problem with the development of the sentence. So for example, in English, if I said, go I, school too, you know that was wrong, right? I mean, that just doesn't make sense. You can figure out what it means, but it doesn't make a whole lot of sense. It's because I've got the syntax wrong. Same thing in Java. If you don't have the syntax correct, you're in trouble. Now, one of the problems with Java is that Java uses, oh, go back. All right, hang on a minute. Where are we at here? Come on. You know, most of the time I can't even get the silly thing to move. Java uses brackets. And the most common syntax error, the most common, is to not have your brackets match. They have to match or it doesn't work. Now we're going to talk about what all that means. So just remember, you have to have the brackets work. All right. Semantics of the program statement simply means that what is this program going to do? What is its role in that program? That has to do with the logic. You know, if you're going to have them input two numbers, then add them together, okay? You can have the syntax right, but if you have them added together before you have them input, it doesn't make much sense, right? So semantics means let's make sure we got it in the right area. If it's syntactically correct, doesn't mean it's logically correct, okay? And this is the one truism that is true no matter what programming language you're going to write in. The program does what you tell it to do, not always what you want it to do, okay? So when you come up with a syntax error, that means you have a problem with Java language. When you come up with the wrong answer, that means you have a problem with your logic. There is no excuse for syntax errors. Syntax, handing a program in with syntax errors is an automatic 0. You need to take enough time to at least get the syntax errors out of the program. Okay, now that should not be a problem because Eclipse will find them for you. Okay. And if I get a program with syntax errors, it tells me that somebody didn't take the time they needed to do the work. All right, so as soon as a syntax error pops up, I don't take the time to worry about grading it because you didn't take the time to do the work you were supposed to do. That doesn't mean I won't help you get syntax errors out. That doesn't mean you can't go to the tutoring center and get help. It means before that program needs to come to me, syntax errors have to be removed. Logical errors, okay, when we run and produce incorrect errors, incorrect data, are different, all right? If I have a logical error, that means my program wasn't designed correctly. And so what we will do in that case is go back and look at the design document. All right? Now, herein lies the problem a lot of students have. They don't have a design document because they would much rather sit down in Eclipse and write the program in Java rather than designing the logic first. And if that's what you choose to do, that's fine. But if you have the wrong answers in your program, do not come and ask me for help unless you also have your design with you. Designing programs is required. One of the flaws when we teach programming languages on this level is that we're trying to teach you the language. So, and yes, we do logic. We do the logic in 168, okay? But when we get to the languages, it's kind of straightforward. We got to teach you the languages. So we often don't get into highly complex programs, or at least you don't think they're highly complex. And so then that means that you figure, I'll just sit down and write them. I don't need to worry about doing all the documentation and the design work. She'll never know the difference. I'll do it after I write the Java. That's a bad idea. It's a bad idea on multiple levels, but it's a really bad idea if you need help, because you won't get any help until you have the logic design done. The concept that you can write the Java program and then go back and do your design work is flawed. A, you either don't go back and do your design work, or B, when you go back and do your design work, it doesn't match your Java program. All right? Let's not have that problem. I know I'm going to, but I'm trying this semester. I promised myself I would try very, very hard. Let's not have that problem. We will design programs first. Ask Nick as you get through here. He's already graduated from here, okay? And if you don't learn how to design it with the easy programs, when you get to those programs, you won't know how to do the design work. All right? Okay, so we can also have runtime errors. Now, runtime errors should have been taken care of in your logic, okay? But they may pop up, and that's one of those things. The only thing that is an automatic 0 is if you hand it in with the syntax error, because there's no excuse for it. It's just a lack of time on your part. Okay. All right. Okay. So when we look at how we're going to do this, we're going to plan. We're going to use our planning document to edit or to create our program. All right. We're going to compile the program. If we have errors, we're going to go back, and however many times okay, now you notice how many times I put that in there. That's not even close to how many times some people will compile that program. But the more carefully you design your program, the more carefully the more attention you pay to detail, the easier it will be for you to get from here to here. Very often, I get students that have wrong answers down here because they had so many typos and other garbage that they didn't pay attention to up here that they've had to compile and to get rid of all of the errors repetitively, so they never have time to get down here and look at the results and make sure your answers are correct. No good, guys. No good at all. You have to pay attention to detail in this class. All right? We'll talk about it when we talk about Java code, but we will pay attention to detail. We will pay attention to syntax so that we don't have to do this. Instead, we can have, okay, and then maybe we have an error once, and maybe we even don't have all of them out twice. But then, okay, we're good to go. Now, you'll notice I don't say you're not going to have any errors. Probably the worst thing you can do is not have any errors. Now, it may be true on the very first couple. Why? Because you have to learn how to fix your errors. You have to learn how to find them and fix them. All right? That is critical. If you don't learn how to find them and fix them, you're going to be in serious trouble. Because what's going to happen is we're going to get to a much more complicated program. You're going to come up with errors, and you're not going to have a clue what to do. I had a student in a programming class one time who was so meticulous, she didn't have any errors until she got to the test. And she was writing the program for a test, and she got an error and had no clue how to fix it. All right? And that's what you don't want to do. You don't want that to blow up in your faces. Okay. All right. Before we start with object-oriented program development, let's take a 5-minute break. 5 minutes is not enough time to go downstairs and smoke a cigarette. Do we understand each other? Okay. 5 minutes. It's 11:30. Be back in here at 11:35. No, I'm going to post the lectures instead. I'm trying not to take up more room on D2L than I have to, because we're always getting hollered at. Okay, so what we're going to do next is talk about the object-oriented part of this. Object-oriented programming is a critical part. Considering it didn't exist when I learned programming, which is, of course, back when dinosaurs walked the earth, right? But the purpose of writing the program is to solve a problem. And we know this from 168. So the first thing you have to do is you have to understand the problem, design the solution, refine the solution, implement the solution, and that's in Java, and then test it. All right? You know, you design it, you implement it, you change it, you fix it. All of those things are involved. The key to designing is breaking it down into manageable pieces. Now, in 168, you did methods, right? Or subroutines, correct? And so you broke it down into more viable, usable pieces. Now, when we do this in Java, you did use subroutines, didn't you? Yeah, okay. I was getting blank looks there, and I'm going, wait a minute. Okay. We're going to look at pieces that might be reusable. Now, and one of the reasons behind object-oriented programming is to allow you to reuse pieces of code. In addition to allowing you to break the things down, we're going to make our items into objects and classes. Actually, classes are a programming representation of an object. All right. Java is an object-oriented programming language. The object is a fundamental entity. Okay. Let's think back to home. Okay. You have a washer, right? Washer has a spin cycle, correct? Okay. Washer has a wash cycle, right? All right. You have a dishwasher. Dishwasher has a wash cycle, doesn't it? Now, both of those are objects. They're appliances. But they're two different types of objects. So what you have when you deal with objects is you have, like, so we say a main class of object, appliances. And then we can break it down into individual objects, washer and dishwasher. Okay? Same thing with people. Now in the school, we have all kinds of people. And all those people have names and addresses and phone numbers, right? Now, students are a type of people. Those students have classes they've taken. They have grades. They have financial aid. Faculty is a class of people. The faculty has classes they teach. They have offices. They have pay. Not a lot, but they have pay. They have various departments they belong to. You have staff. Staff have job duties, because staff is everybody that's not faculty. Right? So staff actually gets broken down into administrative staff, custodial staff, and then maintenance staff. And there's probably some more in there too that I'm not familiar with, all right? So they have some further breakdowns. But do you see how we can take things from the real world and we can divide them up into different objects, all right? Same thing in programming. When I write a program, if I write a program for the school, I have a faculty class. That faculty class describes everything to do with faculty. I have a student class. That student class has everything involved with students. I have a building class. The buildings have rooms. The building rooms have classes scheduled in. So there's all different types of objects that can interact. Objects represent real-world entities. Well, that's what object-oriented programming is all about. We do that when we use objects so that we can create the object one time, and then every time a new faculty member is added, all we have to do is put their information into the object, and we have a faculty member, the new faculty member. Okay. An object has a state, and that's its characteristics, and it has behaviors. All right. Now, state is give me out here. It's properties. These characteristics are called properties. All right. They describe the object. So, for example, Rhonda. Okay. Part of your student object is a name. So you have a first name and a last name. So you're Rhonda Hutchison, okay? Sherry. Your first name is Sherry. Your last name is Castile. So the state of those two objects is different because their names are different. Does that make sense to everybody? Okay. Behaviors. What can it do? All right. Both Sherry and Rhonda are students. Therefore, they are allowed to register for classes, right? They go to classes. those two things would be the behaviors of that object. The student object, both of them have the same behaviors, both of them can do the same thing, but they have different properties. The properties have different values, so their state is different. Right now, they are both in class, so that particular state is fine. All right. Okay. So when we look at a bank account, it's its account number and its current balance. Those are the properties of that bank account. When you look at this, the properties are nouns. The behaviors are verbs. Okay? So we say state of a bank account, it's account number and current balance. Behavior is make deposits, make withdrawals. Make is a verb. Okay? Now, when we make a deposit to a bank account, that changes its current balance, doesn't it? So that changes its state. Okay, and we'll get more into this. All right. All right. An object in programming language is defined by a class. The class is that blueprint. The class uses methods. Think subroutines, okay, to define the behaviors, and properties or attributes to define the characteristics. We have a main method in Java that controls the entire program. The class is a concept, or let's just say object, and the object represents the embodiment of that concept. Okay. Now, this is the important thing. Multiple objects can be created from the same class. Why can multiple objects be created from the same class? Well, how many students are in this class? I told you at the beginning, 18, right? So I need 18 different student objects to be created for this class. Okay, so we're going to look at code. In a few minutes, we'll work through all of this. All right. We have a blueprint. All right. Here we have a red house, a yellow house, and a gray house, or blue, whatever color that wants to be. All right. Now, one blueprint, several different houses, right? Your class is your blueprint. The class that you will write will define how the computer will handle the deposits, the withdrawals. Obviously, if we're talking about a bank account, when they make a deposit, we're going to add the amount of the deposit to the balance, and when they make a withdrawal, we're going to subtract the amount of the withdrawal, right? No problem. Okay, so for every person that has a bank account, each one of those methods, every time they make a deposit, it's going to add it. Every time they make a withdrawal, it's going to subtract it. That's going to happen for every bank account, isn't it? All right. So we've defined that within the programming class, and we've used that class as the blueprint to make the accounts. Characteristics of the account could very well be the account number. So if we assign account numbers 1, 2, 3, 4, 5 across the front row, all right, every one of those would have a method to add the deposit, subtract the withdrawal, right? Okay, now, every one of those would have the first name and the last name, because those are the characteristics in the account. They'd also have a balance. So we have characteristics, properties, attributes, whatever word you want to call them, that define what each individual class is. Just like what each individual instance of a class is. So this is a red instance, this is a yellow instance, this is a gray instance. Okay. Now your states are all different. You have a camo jacket on, you have an orange shirt, you have a black shirt, you have a purple shirt, and you have a plaid shirt. All right. So if shirt was a member of the student class, your states would all be different because you all have different shirts on, right? So when we look at a class, we have to say, what characteristics do we want to define? Now, is shirt necessary for a bank account? No, it's not necessary for a student class either, is it? All right, so that's not something we'd have to put in there. First name and last name is, though, right? So those are characteristics we'd have to keep track of. All right. I define my bank account. All right. My properties in my bank account are going to be name and balance. I don't have an account number, so we'll just do name and balance, right? That is defined here. I have multiple instances of the object. John's, Bill's. Oh, I'll take Bill's any day of the week. Yeah, I would even settle for Mary's, quite honestly, but Bill's would be great. Okay, anyway, each one of these is an instance of the object. Okay, here's where we defined it. Here's where we told it we needed a name and a balance. Here's where we actually implemented it. Okay. Questions? Does that make sense? Anybody? Questions? Okay. All right. All right. Now, we're not going to get into inheritance right now real deeply. We are going to mention it in that, okay, if I have an account has a name and a balance and an account number, okay? Now, name, balance, and account number can apply to a charge account, a bank account, a savings account, a checking account, right? Because they can be implemented, they all have that same thing, right? So by creating a basic account, then what I do over here under the charge account, I have credit limit. Okay? So that is something specific to a charge account. All right? Over here, under bank account, let's just say I'm going to put an account number. All right. And these two, the properties would be a little more harder to define briefly. You know, one you can write checks on, one you can't. Okay, so that type of thing. Okay. So we're going to get to the Java programming language, but before we do, I want to introduce you to programming, my programming lab. I want to show you what we're looking at. And then we're going to call it quits for today. So everybody has a chance to go get, oops, need that, okay, to go get their books. We're hoping this is going to work. I think that's the right URL. I have it bookmarked on my computer, guys, you know. Yeah. Okay. So it's myprogramminglab.com. And slowly but surely it will come up. And we will log in. Now, if you had 170, CPT 170 or CPT 270, and you use my IT lab, which should include everybody in this class, you have already got a Pearson account. So when you go to register, we'll register in a group in class next time. When you go to register, you should use that same name and password. Now, if you don't know what it is, it's okay, and you can use a new one. But if you're in 270 and you're in 187, it's just a lot easier to remember one password. Now, you are going to be seeing my view, okay? When you first come in, and you will register for this class, and I don't think that, I'm not sure exactly how your lobby looks. It may just have the one class, so you would just have to click load. Okay. So what we have here, and this is a major issue I have with this thing. It works great, but I don't have a student view. All right. What we have here, over here, all right, this is showing you how to work that, how to work with this, okay? So this is your code lab warm-up, and we will do this together as a group. Could start, let's start here, okay? Okay, so what I'm going to do here is I'm just going to grab an answer, and I don't know whether they're right or not. Okay. Okay, that was sheer luck. But do you see how it marks it immediately? All right. And when you come in here, you will also have the green, okay, will allow you, tells me it's all right. If you have red, it means it's wrong. If you have either yellow or white, it means you haven't done it. Okay? So the way we're going to keep track of this is we're going to, hang on here a minute. Oh, come on. There, no, that's not what it, I want that middle thing there that's popping up that I can't get to come up. Come on. There we go. Okay. So do you see how I have all of this attempted incorrect, correct late, correct on time? Okay. So that's how I'm going to keep track of your stuff. All right. There's an announcement. These are faculty announcements. I don't know what comes under yours. Yeah, and do you see this? We're putting together some documentation on all sorts of things in Code Lab. Trust me. Trust me. It's not there. This is excellent. I mean, these things are excellent. They really are, like errors. Okay, come on. Oh, let's go back to the work area. Okay. Violation, and this is an example of a short answer. So if I misspell it, it tells me it's incorrect. All right. So what I'm telling you here is there's no reason. Violation of language rules. And I'm putting syntax here. Will be detected at compile time. Yeah. Okay. All right. So there's no reason why you can't get 100 on these things because it tells you right there whether they're right or wrong, and that's 30% of the grade. Yeah. Yeah. And it comes from the book. Well, this is just different. It's different. Yeah, I know you were using the 209. No. Yeah. Well, now you might not think so when you see some of the work involved. Some of the chapters have a lot of questions involved in them, but as long as you do the questions, and get them correct, it's an easy 30% of your grade. Okay. Now, the other thing they have in here. Okay. No, that isn't what I was thinking of. And maybe they don't have any. Yeah, they do. Oh, I'm looking for the one. Oh, come on. There's one here. There are some places, well, and I'm not going to be able to find it, where you'll have to write some code, okay, to make it, see if it's right. All right. And it will automatically grade that. Very. Okay. So, but that will be automatically there. Now, the other thing is, there are video notes, and you will have access to the video notes. And as you see, there are a lot of video notes. Okay? Some of which we may use here in class, I doubt it, but all of which will be available to you. Okay? So that you can look here when you need to. Yeah, that popped up in another window. All right. The other thing I think you will also have available. Now you all have to buy your book in order to get into class, into the programming lab. But there's an e-text, and the reason I like the e-text in this case, the answers to these questions are in the textbook. All right. Now, if you want to work somewhere and you don't have your book, you can open this e-text, and even if you've only got 10 minutes to work on something, you have something available to look the answer up if you don't know what it is. All right? You know what? I'm going to have to find out, because at this point, I'm not sure. The first time we've used this, I just am not sure. Okay? All right. So this is where we're going to go on Wednesday. We're going to take a look at this. On Wednesday, we will pick up with Java. Okay? Once we finish the Java part, we'll get everybody registered in my programming lab. We will also take a look at Eclipse if we have time. So you have to have your book with you. You have to have your student code. I'm trying to think if there's anything else. I think that's it. Okay? Now, I will post this as soon as I get it all recorded onto my hard drive, which should be interesting.